What's up everyone? Today I want to talk about generating collisions when you import your geometry with Houdini Engine inside Unreal Engine. I decided to make this video because it's been a great deal of confusion for me on how it works, and maybe I'm not the only one, and I hope this video might help someone else. The confusion comes from many ways that you can try to set up your collisions inside Houdini and the wildly different results that you get inside Unreal Engine when you actually bake out your geometry inside it. So first of all, let's take a look at the official documentation that we can look as our general guide on how to set up collisions. So there's two of them. There is collision types, which describes all the groups that you need to set up to get a specific collision type inside Unreal Engine. So in general, there are different types of collisions that Unreal Engine can create. And if you go to the Unreal Engine, let me delete all of these. Unreal Engine, if you open up any of the static meshes, all of these types are actually described right at the top of the. I'm sure if you have used Unreal Engine, you see that you can specify what kind of a collision you want to add for your geometry. And what's cool about this that with very simple primitive group, we can automatically set up these collision groups with minimal involvement of the with minimal setup. So let's go ahead and try to set up a simple box collision when we import our geometry inside Unreal Engine. Another help page is great. So this is for the collision types. It's great to know what the exact names of the primitive group that you have to set up to get certain types of collisions. Another one is the setup collision for an asset, which goes through like three examples on how to set up your collisions. Basically, collisions with the simple single collision geometry, and then also how to set up collision geometry with the multiple geometry pieces. So that's also very important for the meshes that needs to be need some like concave entries and all of that. So I'm going to also talk about that one. But at the most basic level, let's set up our box collision for this rubber toy. And only thing that I'm doing, let me go ahead and delete this one. Only thing that you have to do before importing it inside here, you have to set up your primitive group with the specific naming scheme that is required for that specific collision group. In this case, it is rendered collision geo simple box, and this name is sourced from the bottom of the simple collision naming schemes. And for each simple collision, there are two flavors of it. There is a group with the prefix rendered and without it. So the rendered is the most basic one, which means that the collision that we want to, the guide geometry for the box collision or whatever the collision type that you want to select for is going to be the actual geometry that we import. So let's go ahead and try to save it out and take a look at it. So I have baked out geometry. Let's take a look at it. So this is the static mesh toy. Let's take a look at the collision. You can see it has tries to fit the basic box collision the best it could to wrap around the toy geometry. So it is, you can see that it is a little different than the box collision you would set up from the drop down menu inside here. So that's one thing to know, that these collisions are going to be differently because the way that Houdini Engine sets them up, it tries to fit it the best it can. You can see it's has fit it like that, and default is basically, and the default one is just a straight rectangle. So that's one thing to note. But at the end of the day, we have automatically, after the bake, our collision has been set up. So that's not super exciting for now. But another thing that I talked about is these prefixes rendered and the collisions geo simple. So if we give it, we can also create we can give it also a custom geometry that's going to be guide for the collisions. In this case, what you can do to showcase it, I have blasted this one part of the geometry, and I have set up the collision group for it without the prefix, basically saying that this is the collision group that I want to use as a guide for my simple box for my main mesh. In the way that it works, we have blasted it, set up our group without the rendered prefix, and then merged it together with the original mesh. And if we go ahead and try to save it out, let me go ahead and save it out. Let's take a look at the result inside Unreal Engine. I'm going to quickly recook it, bake it. It's going to be create a new static mesh. Let's take a look at it. Player collisions. And you can see that the mesh that was marked and merged together with the original mesh that we actually want to save as a static mesh has been used as a guide for the box collision. And that's actually very interesting. So that means that we do not have to, and that basically means that we do not have to rigidly follow collisions, create our collisions from this exact geometry, because a lot of the times the geometry, some of the smaller parts are not really important for the actual collision. We can use only maybe like this biggest part to set up our collisions from, something like that. So, but this is the important difference between the using of the rendered collision, which means that we do not provide any custom geometry that's going to be a guide for this for creation of the simple collisions, or we want to use a collision without the rendered prefix, and that means that we want to use this custom geometry as a guide to create collisions for this geometry. And what you can do is something like this maybe. Take this box, and let's say my collisions might be, if I want to make a simple box collision, maybe like this, and just squish it down. Let's say I'm happy with this kind of a collision. Again, let's go ahead and try to save it. Should create another static mesh. Let's take a look at it. You can see now we have our basic collision that's guided by our group setup from the simple box. One thing that is not going to work, initially I thought that maybe I can select the subset of the rendered collision geometry, and only that geometry is going to be used to create a simple collision inside Unreal Engine. But in my testing, it's actually not going to work. So I won't even try to. I mean, I can try to show you what's the result. So in this case, I'm not using any custom collision geometry. I am just setting the rendered collision simple box subset. I'm not setting this group for all of the geometry, only subset of this geometry part. Let's go ahead uh, let's try to save it out. Let's take a look at the results. And the results was I guess that results make sense, but it was a little surprising for me. If we go ahead and make it out, you can see that you get two geometry pieces that are being baked out inside the content browser. The one that we have set up our collisions for. If you take a look at it, this paddle player collision, you can see the simple box collision has been set up for this one. And it has also created another static mesh. It has divided into two different meshes, and there's no collision for it. So this is what you do not, in general, you do not want to do, marking a subset of the rendered collision geometry. A lot of the times, a single geometry piece is not enough for us to create collisions for the more complex geometry pieces. So this is where the combination of the different collision geometry comes in handy. So in general, what you would do is basically take a look, some like maybe this sphere, try to fit it maybe around the head, then maybe put down some like a box, and then move it downwards like that. You just want to create these simple collisions. That's going to be easy for game engine to solve when it's being hit, and create something that's good enough for for the usage in something like in games or for player collisions or something like that. In general, this is a way to go about this. But we can also try to and what's cool about this that Houdini Engine also allows us to set up multiple collision geometry pieces for a single static mesh when we bake it out. Let's go ahead and try to set up some collision for this rubber toy. And at the most basic level, again, we have to use our collision geo types of geometry that you want to set up that Unreal Engine supports. In this case, I'm using the capsule type collision geometry. And the only difference is that we have to separate different geometry pieces that you want to set up your collision for. And you have to set up your groups with the suffix, with the individual ID, basically individual with the differentiating integer value. And the easiest way for you to do it is using something like a connectivity node that splits that splits geometry by connectivity of the polygon connectivity. In this case, I went ahead and split the main part of the geometry with the clip node to separate the head and the body of the rubber toy. Merge it, put down the connectivity node, and I'm using the for each loop with the piece attribute. And you can see that I have these individual pieces of geometry that I can try to set up simple collisions for. In this case, I'm setting the simple capsule collision, and the only thing that I'm doing it, I'm having a spare input parameter with the for the metadata, which I am referencing the current iteration account. And at the end of the loop, I have all of these different groups with the different indices at the end of it, from 0 to 10. And the only thing I want to do is go ahead and merge it together with the original mesh and save it out again. And let's take a look at what kind of result we get. So we have only one mesh, that's good. And let's take a look at the player collisions. You can see we have the Houdini engine has tried to best it can to align these capsules around each part of the geometry. And again, you can see that you have the importance of separating the initial geometry into two different parts of the head and the body because of the way that our capsule collisions work. This is the kind of a best way to do it because of if we would have a single piece as our source geometry, we would have basically just a single large capsule that wouldn't really describe the basic shape of the rubber toy. So this is a great way to set these collisions up using the for each loop. Now the downside of this setup is that when we merge this all together, we save out our geometry basically together with the custom collision geometry and with the original geometry that's going to be saved out as a static mesh inside Unreal Engine. So one thing that you can do is actually and if you're saving this geometry on disk, you are increasing memory footprint by quite a lot because of the duplicating of the geometry. So one thing that you can do is actually put down like a poly reduce. You can just go ahead and poly reduce the geometry that's being used as a guide for the capsule or whatever the collision type that you want to set up. Because at the end of the day, this geometry is just a guide for the capsule geometry, for the capsule collisions to be created. And it really doesn't matter how dense our geometry as long as we keep our basic shape of the geometry, what's the density of the polygons are. So we can actually make the geometry quite a low resolution and then create our groups of the simple collisions, and this should work just as well. But the other thing that's not great is that we have to go ahead and merge it all together, the geometry, poly reduced geometry with this one. And if you want to use the geometry, if you want to set up your geometry collisions like inside here, but also I want to use the geometry inside Houdini, like something like a later down the network. It's not really all that great that you see the ugly collision geometry also with the main geometry that is being used inside Unreal Engine. So what you can do is actually put down a visibility flag and hide the collision geometry from the viewport. So the geometry is still there when you import your geometry inside Unreal Engine. It's still going to be discovered. This is just for the viewport purposes. You can hide your collision geometry for the work inside Houdini. When you save it out on disk, it's still going to be there. It basically just hides it. If you go ahead and blast it, you can see you cannot see it, and if you turn off the visibility, you can see it. And if you want to talk about things that you should not try to do, you should not try to set up multiple simple collisions for your geometries with the rendered prefix. So the idea would be that if we do not create any, the idea is that we do not create like a guide geometry for our collisions, and we straight up set up our collisions. We try to set up our collisions straight up on this geometry. So let's put the rendered collision geo simple. You can see the geometry has been set up just the same, but in this case we do not have a we are setting up it straight on the same geometry piece on the same geometry that we want to use as our static mesh inside Unreal Engine without like a copy of the geometry or like a guide geometry with the rendered prefix. This worked for our single geometry. This worked fine when we wanted to set up it. We wanted to use rendered collisions for a single geometry piece without the copied guide geometry. But in this case, it's not going to work with all of these suffixes, and I'm going to show you why. If we go to the Unreal Engine, let's go ahead and try to recook it. You will see that for each one of these entries of the rendered collision group, the Houdini Engine has created a new geometry piece. So this is in general, this is not what you want to do when you create these kinds of player collisions. But you can see the collisions have been set up for each piece. But the downside is that there are individual static meshes for each unique indices for the collision group. So this is what you should avoid doing when you create your groups. And the last thing that I want to talk about is automatic setting up of complex collisions. So there are two groups that you can set up to automatically create complex collisions. So there's a rendered collision group, Geo, which basically in my experience just sets up some parameters from the detail tab of the static mesh panel. Let me go ahead and take a look at it. So again, render collision geometry. Let's go ahead and try to save it out, and let's take a look at the result inside Unreal Engine. So in general, the complex collision inside Unreal Engine means that instead of us creating simplified collisions using these kinds of a mesh, these simple meshes that are easy to work in runtime for video games, we use the actual vertices of the static mesh as a collision check geometry. That means the complex collisions. So these collisions aren't really used in video games. These are just maybe in somewhere where the performance and the predictability of the uh, collision checking is not important. So, but basically in video games, these are not really used. These kind of a high resolution mesh are not really used. But the only thing that this group setting of the group did inside Unreal Engine is if you go to the collisions tab, drop-down menus for the detail panel, you can see there's actually ability to use complex collision as a simple. If you go ahead and disable it, player collisions, and we go ahead and say again, use complex collision, you can see it basically set this entire mesh as a simple collision. So as far as I have noticed, this is the only thing that has been set up inside here by us setting up this rendered collision geometry group inside Unreal Engine, inside Houdini, and importing it like that. So this is the only thing that I have noticed that has changed. Now let's try to do the other one. Let's try to set up our custom complex collision on. In this case, what I'm going to do is instead of render collision geometry, and I want to use this pig head as a custom collision for my rubber toy. Let's go ahead and try to merge together, and let's see what we get. You see these collisions are not great, but to check it out, we can see that basically if our collision is this big, our complex collision is this big, we should be able to fly through the head of the rubber toy, but not through the body. Let's go ahead and take a look at the results inside Unreal Engine, which I was a little surprised at first, but it actually makes sense. The results actually make sense if you think about it. We can see that we actually got two geometry pieces baked out with this group setup, which makes sense because we need our complex collision be set up for our main big geometry, our rubber toy. You can see that Houdini Engine has created this geometry, this complex collision geometry, and what it has done inside the main rubber toy, it has gone to the collision customized collision. It has checked this to true, and it has set this big head as a complex collision mesh. So we have completely custom complex collision mesh set for this rubber toy. And the only thing that we have to make sure that we actually use the collision complexity. By default, it doesn't actually set this to use complex collision as simple for our camera to actually to be blocked by the collision. We have to set up use complex collision as simple like that. And now you can see that even though our collisions are not, our big head is not being showed as a collision, if you go ahead and try to go through it, you can see we can easily fly through its head, but if I try to fly through its body, we cannot. So this gives me an indication that our complex collision is now being used as a simple one, and our complex collision is actually our pig head. But this basically finishes up this video, this demonstration. I hope you learned something, and see you next time.